End of the second day, almost ready for the party. I don't see any party atmosphere here. No, not really. Highly technical conference, and you see two people from a bank. They are going to be talking about technical things. That's interesting. So we are not a famous tech company. We're a bank. But apparently we've got massive amount of data. We've got billions of transactions. And there's one more thing that a bank has. It's trust. It's the trust that you have a trust in bank, that whatever you put in a bank is safe. So basically, if you combine data and you combine trust, this is our responsibility to manage data, to process data in a responsible way. This is a challenge on our side. This is the challenge we like. It's the challenge that we approach. And is there Kubernetes here? Let's find out. So we start our mission, and the aim is ambitious. The goal is ambitious in front of us. We would like to be a platform that is being used widely across ING by 50% of our employees. 50% of 50,000 employees across the world. That's our ambitious goal. Secure and responsible way. And we would like to achieve that goal in 2 years' time. But if you work in a bank, that's not a greenfield. So we haven't started like from scratch with a blank page. So obviously there's a history of data warehouse systems within the bank. There are some BI systems. When we started, we set up the team, the advanced analytics teams 5 years ago. We already started with Hadoop stack. It was a standard stack back then that you build your platform on top of this. Obviously, we embrace the scalability capabilities of Hadoop. You can scale Hadoop into thousands of nodes. That's not a big deal. There were some limitations of that stack. And Holden, during her sessions, scratched the surface of these limitations, like managing Python dependencies, like managing these tens of conda deployments or Python, different versions of Python packages. This is something that we faced back then. But there's also something different. So there's the known problem of cows versus cattle. Whenever you manage your Hadoop deployments, basically you know your servers by heart. You know their names. These are pets to you. These are these cows. And this is something that it shouldn't be like this. You shouldn't have a relationship with your servers. If you don't like them, you should break that relationship. You should release those machines. That's the way how I see it. Another problem, maybe managing the Hadoop versions, upgrading the Hadoop stack and, if that's really going to work, it scares me that I need to upgrade the whole platform, that I cannot upgrade the components independently. That's something that we really don't like back then. But when we decided to start our journey, we said, okay, we are talking about technology, but what is important for us? Let's start from user journey perspective. So we have to our goal is to put the data, put the tooling in one place to guide our users on the journey. So basically, we would like to democratize data, democratize tooling. That's why putting your user in front is the start of our journey. Also, being cloud ready, cloud native, that's what we think about. How to prepare ourselves, how to prepare we are working in a bank. Bank is not like the first industry that goes into the cloud, but how to be prepared into that movement that will happen eventually. How to prepare the architecture to be ready for that movement to the cloud. The rise of microservices. We were observing Kubernetes back then. It's a 5-year-old project. I was observing this project, from the early beginning. We were using Docker for local development, but using Kubernetes to manage data, to build data pipelines, that wasn't an obvious choice. I was using this for serverless for stateless applications, for web applications, but not for data processing. But something is changing. So we've got the benefits of Kubernetes, benefits of isolation, benefits of resource management. The project like Spark on Kubernetes that emerged gives us excellent possibilities to go into that step, to become cloud native. Closing that gap. Over to Europe.
Okay, thank you. Can you hear me? Yep. Cheers, Chris. Okay, so probably time to talk some architecture about our solution that we settled on for this challenge. It is called the Data Analytics Platform. And we intend this to be a platform as a service, initially inside ING. We're hoping to also take it to other places in future. And to be a platform as a service, you need a number of things. Firstly, you need a front end. You need something that guides your users as they make their journey through your product. They need to be handheld to show all the tools they can use, how they should achieve their jobs normally, and not having to constantly refer back to a user manual. And that should add some sort of consistency to your product. It should feel like a coherent whole. Secondly, you need a compute framework. We need something within this platform that is going to be ultimately running these data science workloads. And based on the lessons of the past, we didn't want this to be too opinionated. We wanted it to be agnostic to the technologies. So we wanted data scientists to be able to choose the latest and greatest technologies of the day. And we don't want to have to manage them as separate clusters. We don't want a Spark cluster, a Flink cluster, and Technology X that comes out next year. We want a framework that can handle this. And yeah, spoiler alert, we're at KubeCon. It's Kubernetes for us. Being a bank, we have lots and lots of data. We have multiple petabytes coming in every year into this platform. Quite different types of data, obviously transactions, but also trades, click streams, things like that. And we want to be able to hold this in a high-speed cache right alongside where the data scientists need to do their work. We'll be going into that. But also, our data must be kept into certain separate areas. Certain types of data can never be combined in a bank. Certain users should never be able to see certain types of data. So whatever data system we select needs to have really quite fine-grained access controls. Finally, running through all of this, we have a load of security and integration tooling. We have thousands of users using this platform, thousands of production pipelines, and we need full traceability of this. We need to know exactly where our data is, where our data was. If we get asked to describe why this model gave this certain result 3 years ago, we have to be able to, within a number of days, go back, replicate everything, and work out what happened. So we have a whole suite of tooling running through our whole platform to deal with this. So let's drill into one of these sections. So the first thing a user sees when they log into the platform is our DAP Portal. And this is precisely what I mentioned. It's a web interface that shows you all the things you can do as a user. It has a service catalog with all the tooling you're allowed to access. It has a file browser to view our storage cluster. And it has ultimately an environment where you can define all your dependencies, how you want to do your job, and provide you that environment as a data scientist. Interestingly, we found that one of the main bottlenecks to a data scientist, once they have a good working platform with all their tooling, is actually just understanding the complex data environment within an organization. ING is a very large multinational bank, lots of geographies, different industries, legacy systems, modern systems, and just understanding I have to solve this data science problem, what data do I need to look at, is a really significant challenge. So for this, we actually formed a partnership with Lyft, the transportation company in the US, and we built an open source product called a Munson, which is what you see behind me. This is a search-based interface. You start presumably looking for a certain class of data, and you can then drill into that data. It will show you the obvious things, like the metadata for that data, who owns it, when it was updated, metrics around the data. But also it shows other things. So it shows the social nature of that data. Perhaps you work in a similar department to a power user. It can recommend you what data sources you should probably be looking at. It can also show you things like access patterns, how useful do other people in the bank find this data. The coolest feature of this platform for me is also, when combined with Lineage, which we will go into later, you can also see what people did with this data. So here I have a data source called grid. I can see that maybe other data scientists in my department have already enriched this. They've maybe geocoded it with lat longs, so I'm ready to do my geospatial analysis without having to do that work myself. And that's all exposed via this tool. As mentioned, it's an open source project. If this sounds like an interesting problem for you, an interesting tool for you, go and check it out. And as always, contribute back and help us in this challenge. One issue with the DAP portal being a web interface is it itself could be a security vulnerability. It has an interface for you to fire off a SQL query and to return data. And there's nothing stopping you then copying that data onto your local laptop. And no surprises, in a banking environment, that is a very bad thing. We don't want users being able to take data onto a portable device or a non-secure device. So we need the nature of a jump host, a remote desktop. And here, Kubernetes comes to the rescue. There are commercial VDI solutions about, but we wanted to build our own open source platform. And we needed it to be scalable and secure. So what we did is we took the XRDP project. We gave them a couple of pull requests. So we added in the ability for you to copy into your remote desktop, but not copy data out. And then we quite simply wrapped that in a container. We have a web interface when you first sign to the platform that spins every user up their own dedicated container on demand, deploys it into our cluster, and Apache Guacamole then exposes that front end into the user's browser. We're super happy with this. It was quite simple. It took us about a week to achieve. The performance is great, and every time we get new users, we can just add more cluster resources. We're not paying for our own VDI server farm. We built one very simply using Kubernetes primitives. And this has been excellent. Okay, let's talk about the compute part of our framework. So here, we think of Kubernetes in a slightly non-traditional way. The sort of classic bread and butter of Kubernetes is to take a long-lived stateful service or non-stateless service and to monitor it for user load, to auto-scale it as needed to make sure that service is always available, to deal with failover, redundancy, rolling upgrades, those kind of things. And we definitely need that. So the front end I just described needs all of those concepts, and Kubernetes is great. But we also have the second challenge, which is the multi-petabyte analytics workloads. And these are slightly different in that they should scale up rapidly to all spare cluster resources so that that workload can be computed as quickly as possible and then scale right back down to 0 to keep the cluster available to other users. What makes this even more challenging is we need those two patterns to exist on the same cluster. We don't want to be managing separate clusters for separate technologies, as I mentioned. So we did a lot of work within Kubernetes on concepts like auto-scaling, quality of service, and resource classes, things like this. One interesting thing is this is a data science problem in itself. So we turned the platform onto itself. We recorded all of the scheduling data that the platform gives us, so we can see peak loads, we can see when different types of workloads come up, and we can just over time look at times where the cluster maybe didn't perform as well as we would have hoped, and just keep adjusting our quality of service rules over time. So it was quite a nice use case of using the kind of technologies we're enabling to actually improve the technologies themselves. Data science in a box is perhaps the main part of the platform. It's the real sort of critical tool we have because data scientists are our main audience. It's ultimately a platform where ING data scientists can come in to do their experiments. They're a valuable resource and a scarce resource. And we found with our old platforms, they were spending up to 80% of their time not actually doing any data science at all. They were doing things that feel much more akin to infrastructure work, like installing their own Jupyter labs, or data engineering work, trying to work out the complicated data structures and cleaning them up ready for their actual modeling. So data science in a box is purely aimed to speed up this process. So what this is actually a dedicated Jupyter Lab environment for each user. And in the portal, they have an interface where they can select everything they want about that environment. They can choose their language, R, Python, Scala. They can choose computational frameworks like Spark or Flink. And they can also add in any operating system packages they need, Python packages, things like that. That will then launch them this dedicated, isolated environment, and they can do all their remaining work inside this platform without having to be infrastructure experts. It also attempts to have everything ready for them. So all the data that that user is allowed to access, we can look that up in our authorization system, and we can pre-mount that into the container. So they click the button, they get a Jupyter Lab, and all the data is right there for them. Architecturally, it looks like this picture. So the user logs into the DAP portal, and they type their requirements into this interface. Behind that, we have quite a lightweight API we call Callisto. It's tracking the state of all builds that we've fired up in the past. So if a user has already requested this pattern, we can just provide that image straight to them. Perhaps the image is out of date and needs rebuilding for the latest vulnerability patches, then it will trigger a new image to be built for that user. And currently that's just sending commands into a GitLab pipeline. We're also looking into Canico for this for better scalability and security. The image is then loaded into Artifactory, and the portal tells the user that it's ready, typically in about 20 seconds. At that point, the user can select that image, and then they can describe their resource requirements. Perhaps they need lots of CPU, but not so much RAM this time. Perhaps they need GPUs. In future, we also hope that you can select your public cloud that you want to use here, and that can then deploy that image into the cluster and forward you directly into your Jupyter Lab page. Let's look into the storage element of the data analytics platform. So as mentioned before, we wanted one single framework to do all of our storage needs. And it had to meet a whole different host of use cases. Obviously, it needs to be a highly performant, highly scalable storage system for us to hold all the data we need. But also we need things like block storage, we need file system access, and we want cloud-native APIs for this as well. And it also needs to be able to serve persistent volume mounts for Kubernetes. And we found Ceph to be a really excellent fit here. It met all those requirements, and it's also blazingly fast. So we have the Presto SQL engine. If we're querying a table hosted on S3 in Ceph, we currently get about 10 billion records a second on a relatively complex SQL query. So when you have years and years of transactions around the globe, you can, in 1 or 2 seconds, get some really complicated analytics back just using simple SQL. One area where Ceph did come up short for us, surprise, surprise, is in the security domain. And open source projects tend to have security as a little bit of an afterthought. Particularly the thing we needed was the fine-grained access controls. We want to be able to say precisely this user in this team, these are the models, these are the data points, these are the types of actions they're allowed to do at every single level in Ceph. So we built another open source tool, which we call Roku, and there's a link to it here if you guys want to check this out. What that's doing is intercepting every S3 or file system command into Ceph, and it's checking that the user has an OpenID token from our Keycloak server, our single authentication provider. And also it's checking authorization in Apache Ranger. If a user is trying to do something that they're not allowed to do or haven't been enabled to do yet, then the Roku proxy will reject the request. Also, Roku adds the concept of short-term tokens. So we can give users time-based access to this system. So if a credential somehow was able to be compromised, it's only going to be active for a short amount of time before that token gets refreshed and replaced. So lastly, let's look into the security and integration part of our toolkits. So security has been the single toughest challenge of the DAP platform. And this is because we're really trying to do 2 conflicting goals. We're trying to bring cutting-edge technology to a bank, but banking is one of the most heavily regulated and trusted or untrusted industries on earth. We have to we can't just bring in insecure technologies for the sake of doing data science. We have to always keep that security element. The problem of security in an open source world is actually a problem of proliferation. If I want just, let's say, 3 big data tools, Flink, Spark, Presto, whatever, I rapidly have 20, 30 tools because you look at the different authentication systems, back-end databases, config management systems. There's not the biggest amount of overlap in a lot of these places. And that's a security nightmare because in this kind of environment, all those tools need to be penetration tested regularly. They need to be monitored for vulnerabilities. And it becomes impossible to manage at a certain scale. So this platform has taught me that my new favorite number is 1. To maintain this platform, we'd had to choose a single technology for each concern. We can't have multiple authentication systems. We settled on OpenID Connect using Keycloak. And that meant most of our development efforts actually went into open source commits, bringing OpenID support to technologies that don't necessarily support this. Another key example there is Apache Ranger. We use that for saying what users are allowed to see. We needed that to be a single authorization tool because we don't want to be saying what can this user see and then looking through 4 or 5 different dashboards to see what his permissions actually are. So to stay in control, we made this one tool for each concern.
Can I have a clicker? So how does it work, actually? So basically, a user wants to analyze some data sets. He gets an access to parts of the data set for a certain period of time. So we assume a role for a user. For example, it could be that one of our employees wants to analyze how competitive our mortgages are in Belgium. So a user has an access only to this particular data set, only for a few hours, for example. When all the analytics is done, it can persist the data in the underlying storage subsystem. In memory, the data set is encrypted, separated in their own namespace. In the persistent storage, it's managed centrally by Roku and Ranger. So this is how it goes. How is that possible? So that we track the data. We basically track the data from the source to the very end of the report. That's one of the main principles, one of the goals of the platform, that we have to know where this data coming from, what's the end of the data. We are using tags, so tags being attached to data. By this example, we are doing some smart things. So we know if there are some public data being analyzed by user, that's only public data, can be available to anyone. But also the tags being inherited. So if someone analyzes specific type of data, this tags follows the data till the very end. That's we know how to what kind of central policies have to be attached to this data set. We couldn't find a proper tool in the open source world that managed that data governance is pretty non-existent in the open source world. That's why we backed up on Apache Atlas, and this is why it's an open source project, and we are very much keen on building all the data governance on top of that. What I have to highlight is it wouldn't be possible basically without a perfect team, the great team that we have that we work with. We just highlighted the nations that the guys are coming from, that are building that team, building that platform. It wouldn't be possible without them. Some of them are on this audience. Some of them are still working hard, making that platform even better. People with different skills, front-end, back-end engineers, ops engineers, but even guys from non-financial disks that are helping us, making it possible within a banking environment. And we encourage you not only to join that team, but also join the open source projects that we are building. Rob mentioned Munson that we're building together with Lyft. Please join us and build something around data governance with Apache Atlas, because this is something that is pretty not existing in the open source world, and which have to make sure to analyze data in a responsible way, to make sure that what we are doing is good for society, good for the humankind, that we are doing this manageable way. So thank you all for joining our session. I hope you enjoyed it. and have a great party. Any questions from the audience?
Yep. I can be microphone guy.
Microphone guy.
You told that the data analytics platform is open source. Can you give us the GitHub link or the reference?
The whole platform we also plan to open source. The parts of the platform, basically almost all the components that we show in the maps are open source like individually. The platform as a whole, we plan to open source creating something like DAP in a box, so you'll be able to spin it up yourself. At the moment, there are parts of the components that you can set up yourself, but it's not like a platform as a whole. But we plan to do this in the form of Helm charts, for example. We have a couple of the components that are already available like this. But yeah, definitely we have that in mind to have the whole platform open source.
Okay, but the link of the separated component, where I can find them?
You can look. There was a link to Roku. That's like a first starting point. But if you are interested in special parts, just reach out to us and we will help you to guide you which components are where you can find the proper tools. At the moment, we don't have the full platform open source.
Yeah, and we have some commercial components, just a couple, because we need container security. There's no good container security platform open source that I know about. So
there are some products on the market, but not as good as a commercial offering. So yeah, we have to choose wisely. Yeah, so if there are good commercial products in terms of security, well, we are a bank. That's a top priority. It's a trust. Yes.
Okay.
Any more
questions?
Hi. So all the containers that you run from a user interaction are built automatically by the platform. So no user brings their own Docker image, for example. Is that correct?
You can pick this up, yeah, if you want.
So yeah, currently everything is built inside the platform for a few reasons. Firstly, it's what our users are, it kind of fits their skill sets. So the data scientists are not necessarily the kind of people who naturally are building Docker containers left, right, and center. We do, however, have data engineers and people like that also using the platform. And we do hope to support the ability to just submit your containers. There are some complexities there. Like we ultimately have a small set of base images that have certificates loaded in, certain types of monitoring loaded in. So we need to build it so that you're essentially submitting something more like layers than actual complete images. Yeah, we can't allow people to obviously submit containers full of vulnerabilities onto the platform, that kind of thing.
So we scan the containers for vulnerability, but as Rob mentioned, the base image that we have, that's something that we propose. They can build, developers can build on top of that. And integration with the whole enterprise layer, the certificate authority that is custom for our enterprise, yeah, that makes it easy for them to, based on our image, than relying on something from the internet. Yeah? So it's good for their local development testing, but productionizing it, they should stay with our base images. That's the end goal.
Cool. Any more questions? Yep, I'll run over there.
You gonna run there or?
Sorry, where was this? Yeah.
Thanks. I wanted to ask about the integration you have with Roku and Ceph. Did you notice any performance problems? Because you have every request going through Roku and authenticating.
Can you hear that about Ceph integration and problems, performance problems with Ceph? Between
the user's request going through Roku and finally going to Ceph. That's
not sure which stage you are talking about saving the results or about spinning off the new image,
the results, yeah.
The results.
Saving the data.
No, we haven't seen, especially not with Roku. Roku is a proxy, but it doesn't cache anything. So basically, Ceph is highly scalable infrastructure. So we've got multiple Rados gateways set up, and that's yeah. So basically, it's load balancing between them.
Thanks.
We haven't found any performance penalties on this. We are fully utilizing whatever we have on the network layer. So obviously, if we have a faster network, then we can go even faster, but at this moment, like it's blazing fast.
Yeah, I'd agree with Chris there. It's our bottleneck is the network bandwidth.
So I guess everyone at ING is for now is astonished that they can crunch the whole history of ING transactions in a matter of seconds. So basically, that's how it is.
Yeah, maybe an extension to that, because I mean you can also integrate like the Rados gateway directly with Keystone and get basically the request authenticated by Keystone for you, but the issue is that Keystone it has absolutely no caching and it's actually quite slow. So
We do not use Keystone. Yeah, so
yeah. I mean, if you have the Keystone integration for Ceph happening there, so I think that's the what's behind the question there. Because I mean, if you do like some serious like loads or like on the object storage, then I mean every request gets separately authenticated against Keystone. So I don't know how it's with the Roku. Is there any caching mechanism? So.
Authentication requests, yeah, these are being cached. This is an ACA layer on top of Roku, but we are not using Keystone. We are using Keycloak, so OpenIDC, so one of the frameworks.
So if you have a cache, you don't have similar issues. But anyway, so
yeah, we do not face those challenges. If we face the problems of the performance of the storage, we are much more looking into Alluxio to create a cache layer that's going to be an in-memory storage layer that we are looking into. But at the moment, we haven't touch the problem, so if there's no problem, just don't create one yourself. So basically, we are limiting ourselves. We don't want to pick up, as many components as we want. If we touch the problem, then we're gonna resolve it.
All right. Okay. Cool. Thanks.
Yeah, no problem. One more question over there.
Hey, there is some overlap between Munson and Apache Atlas. Why actually use both?
You want to pick this up, Rob, or I can do this?
So, Munson and Atlas. Atlas is a very good lineage tool in terms of it's like a registry of all lineage. I can query it with an API. I can store that at quite large scales. As a front end, it's not really user ready. Yeah. Munson is purely designed for your actual users, your data scientists, to search for their data. We actually added the Atlas backend into Munson. Munson on the lift side was using Neo4j, but now it's got pluggable backends. And yeah, we basically made a user-friendly UI for Atlas. Yep. Okay, how are we doing for time? Any more questions?
Here from the front. Yeah.
The front, okay.
I would pass you my mic, but I'm not sure if it's going to work. Rob will just make more steps.
Yeah, I'm getting my exercise.
I'm curious about the GDPR compliance. You talk about the tagging. I don't know if you created the standard or use your internal standard to tag columns to manage composition of data and to follow this data up to their usage. So how you are managing this?
Yeah, I'm an expert at that. You want to pick this up, the GDPR standards?
Yep, so ING have massive legal departments whose sole job is this problem. We do have internal standards like C classifications of data. So data can be C1, which is essentially open, all the way up to C4, which is this needs to be on encrypted hardware where no users can ever access. Within that, so one of our tags is the C rating. Also, all data that comes to us from a data lake, the columns get a tag that describes what type of data it is. So if we have a date of birth or an email address in there, that column will get tagged. And that column is the lineage that we track. So if I do a join and take that email address and add it to another data set, that data set gets promoted to being a C3, C4 data set. Yeah. Okay. Any final questions?
Otherwise, you can, we're going to stay here, so you can reach out to us.
Thank you very much, and enjoy the party tonight.